Hello, guys, welcome all of you to the Study with Me YouTube channel. So, today we are going to learn about the equivalent fractions. What does it mean by equivalent fractions? The name itself tells you equivalent means the fractions are equal to each other. So, you can see in the example that I had taken, the first fraction is 1 upon 2. The second fraction is 2 upon 4. And when we go down, it's 3 upon 6, 4 upon 8, and finally 5 upon 10. So, when you see the part of each figure, the part which had darkened, that means the colored portions, you can see the first part is this one. It's 1 upon 2. The second part is 2 upon 4. When it compared the colored portion of each figure, when it compared with the size, you can see they all are equal to each other. So, because of that, we can tell that 1 upon 2 is equals to 2 upon 4. That's true, right? Here you can see 1 upon 2 and 2 upon 4 are equal to each other, right? Likewise. And also what? 3 upon 6, the colored portion, is also equal to the fractions that we wrote earlier. And what comes next? Then 4 upon 2 here, sorry, 4 upon 8. Here the color portions, this is 1, this is 2, this is 3, and this is 4. They are equal to these, for example, 1, 2, 3 portions. So again, due to that, 4 upon 8 also equals to 3 upon 6, 2 upon 4, 1 upon 2, and finally 5 upon 10 also equals to each other. You saw that, right? But when you compare the denominator and the numerator of all the fractions here, for an example that I had taken, uh, this is 2 when it what I'm doing is I'm comparing the denominators. This is 2 and this is 4, this is 6, this is 8, and finally this is 10. So they are different, and even if you compare the numerators, this is 1, this is 2, this is 3, so you can see the numerators are even different. But the point is the value of these fractions, each one of these fractions are equal, right? Here you can see everything from these five figures that I had taken. So this is why we call them equivalent fractions. You can see the value of each of these fractions are equal when you see these figures, but their numerators and the denominators are different to each other. So such fractions we call as equivalent fractions. Understood? I hope you got it. Great. So mainly, there are two methods of obtaining equivalent fractions. The first method is multiplication, and the second method is what? Division. So let's see some examples, and I will explain you how you can get the equivalent fractions by using multiplication method, which is the first method we are going to talk. So, in this section, what you have to do is you are going to multiply both the denominator and the numerator by the same value. So, let's take the same fractions we discussed earlier. So, 1 upon 2, 2 upon 4. So, I told you that 1 upon 2 and 2 upon 4 are equal to each other. So, how do you calculate them? You can use the multiplication method to get those values. So what I'm telling you is, I'm telling you 1 upon 2 is equals to 2 upon 4, and they are they are equivalent fractions. So how do you get 2 upon 4 from 1 upon 2. What you can do is you can multiply both the denominator and the numerator by the same value. Here, if you multiply 2 by 2 and also 1 by 1, 2 by 2 and 1 also by 2, what do you get? 1 into 2, here 2, 2 into 2, it's 4 here. So now what happens? I'm saying that 1 upon 2 and 2 upon 4 are equals to each other, kids. So how does it come? If you divide 2 by 2, 2 divided by 2, what's the value? It's 1, no? So if you multiply any value by 1, if you even multiply 100 by 1, what's the value? It's 100. If you multiply 80 by 1, what's the value? It's 80. So if you multiply any value, it doesn't matter about what the value is. But if you multiply any value by 1, then you get the same value. So that's the same thing which applies here as well. If you multiply 1 upon 2 by 1, here 2 upon 2 is 1. So here you can say it's 2 upon 4. But what I'm telling is 2 upon 4 is equals to 1 upon 2. Understood? So that's why they are becoming equivalent. Got it? You got the point. Great. So shall we do another example? Let's take uh, let's calculate another equivalent fraction to 1 upon 2. In here what I'm doing is I'm multiplying both the denominator, which is in the bottom, and the numerator by 3, right? Both the values are multiplied by the same value. So 1 upon 3 is 3 and 2 upon 3 is 6. So 1 upon 2 and 3 upon 6 are what? What? It's they're called equivalent fractions. So shall we come up with another example? Now think about this. 1 upon 2 equals, equivalent fraction for 1 upon fraction for 1 upon 2. It's what I'm doing here is I'm multiplying both the numerator and the denominator by 4. So 1 into 4, it's 4. 2 into 4, it's 8. So 1 upon 2 and 4 upon 8 are equivalent fractions. Equivalent fractions. Great. Shall we come up with the last example? So what I'm doing here is I'm multiplying 1 upon 2, both the denominator and the numerator. I'm going to multiply them by 5 upon 5. Right then, 1 into 5, what is the value? 5. You know that. 2 into 5, what's the value, guys? It's 10. So 1 upon 2 and 5 upon 10 are equivalent fractions. So what I'm telling you here is there's another thing what I need to mention here. 2 upon 4, 1 upon 2, 3 upon 6, 8 upon 4 upon 4 upon 8, and finally 5 by 10. All of these fractions are what? Equivalent fractions. Okay, that's the first method which comes with multiplication approach. So now let's go to the division approach. Divide both denominator and the numerator by the same value. Right. Now let's take a fraction we had done here. For example, let's take 3 upon 6. 3 upon 6. Right? 3 upon 6. What I am doing here is I am dividing both the numerator and the denominator by the same value. Here for an example, I am dividing both the numerator and the denominator by 3. Right? So what happens? 3 divide by 3. What's the value? It's 1. 6 divide by 3, what's the value? It's 2, right? So what happens here is, how do you tell that these 6 upon 3 and what 1 upon 2 are equivalent? Again, the same thing I told you. 3 upon 3 equals to what? 1. Then if you divide 3 upon 6 by 1, then it's again 3 upon 6, right? But here, if you divide both the denominator and the numerator separately, you get 1 upon 2 as well. There are two ways. So what I can finally tell is that 3 upon 6 and 1 upon 2 are equivalent fractions. Great. So let's do another example. 5 upon 10, right? What I'm going to do here is I'm again dividing same the denominator and the numerator by the same value. Here I will take 5. 5 upon 5. I'm dividing both of them by 5 upon 5. So 5 divided by 5, it's 1. 10 divided by 5, you're multiplying for this side, not for this side, okay? Right? 5 divided by 5, it's 1. 10 divided by 5, it's 2. Again, what I can tell here is 5 upon 10 and 1 upon 2 are equivalent fractions. So you saw that you can take the answers, you can find the equivalent fractions by both of these two approaches, either by using multiplication approach or the division approach. Okay, now here we comes up with an example. Let's crack it. It's easy. Right, what's the first one? Write down two fractions equivalent to 2 upon 10. 2 upon 10. Yeah, here I'm showing it like I will use multiplication approach. What do we have to do? We have to multiply both the numerator and the denominator by the same value. Here I'm multiplying the denominator, I'm multiplying the numerator as well. So here I have taken 4, right? It doesn't matter, take any value you like. Then 2 into 4, it's 8. 10 into 4, it's 40. So what I'm telling is 2 upon 10 is equivalent to 8 upon 40. Great. So I will take another example. I'm multiplying 2 upon 10 by both the numerator and the denominator by 3. Then 2 upon 3, what's the value? It's 6. 10 upon 3, what is it? What is it? It's 30, right? So they are equivalent. So I will show you for the same example. I will show you a fraction. Sorry, I will show you a division as well, right? Here, let's take 2 upon 10. I am divide both the denominator and the numerator by 2. Then 2 divide by 2. What's the value of 1? 10 divided by 2, it's 5. So 2 upon 10 and 1 upon 5 are also equivalent fractions. Great. Okay, what happens here? For each fraction below, write down two equivalent fractions. So I'm here taking the first one. It's 1 upon 4. It's easy. So what I'm going to do is I'm going to multiply both of the numerator and the denominator by 2 maybe, whatever value you like. Then 1 into 2, it's 2. 4 into 2, it's 8. Let's take another example. What I'm doing is I'm multiplying both the values by 3, both the numerator and the denominator. Then 1 upon 1 into 3, it's 3. 4 into 3, it's 12. Okay, now let's come to the second example. It's 3 upon 5. What I'm going to do is I'm going to multiply both of these values by 2 maybe, right? That seems good. Then 3 into 2, it's 6. 5 into 2, it's 10. I'm taking, I'm writing down the same thing again. And here, this time I'm going to multiply both the numerator and the denominator by 6. Then 3 into 6, it's 18. And 5 into 6, it's 30. So 3 upon 5 and 6 upon 10, they are equivalent. And also 8 upon 30, 18 upon 30, it's also equivalent. Great. Here you have another example here, right? You can come up with any, I mean, multiply both the values, numerator and the denominator, by any value that you like. Do you want me to show an example here as well? The answers for them as well. So it's okay. I'm multiplying both of them by 2, both the numerator and the denominator. Then it's 7 into 2, it's 14. 8 into 2, it's 16. So you can come up with another example that you like where you can multiply both the numerator and the denominator by the same value. And here comes another example. Here, instead of showing uh, two equivalent fractions, I will come up with one. Here you can see I can use a division method here. 6 upon 12. What I can do here is I can divide both the numerator and the denominator by 2. Then 6 divided by 2, it's 3. 12 divided by 2, it's 6. And also, I can divide 6 upon 12 by 3 as well. Both the denominators are getting divided by 3. So, 6 divided by 3, it's 2. And 12 divided by 3, it's 14. 4. Sorry, not 14, it's 4. Right? Then finally, here comes another example. 8 upon 10, where I can divide both the numerator and the denominator by 2. So 8 divided by 2, it's 4. And 10 divided by 2, it's 5. Great. And then let's write it again. Here I divide both the numerator and the denominator by 4. 8 divided by 4, 2. Here, not 4. 4 doesn't work here because 10 and divide by 4, you won't get a whole number. So what happens is, don't take this, okay? Instead, take another example. What can we take? What can we take? Nothing you can get by dividing, no? We have to add 4, no, nothing goes here. So what you can do it, you can go for a multiplication approach. Here, let's multiply both the values, numerator and the denominator, by 2. So 8 into 2, it's 16. 10 into 2, it's 20. So what happens here? I'm telling you that 8 upon 10, 4 upon 5, 16 upon 20, all these three values are what? Equivalent to each other. Great. So finally, here comes our final example. Determine whether 2 upon 4 and 6 upon 12 are equivalent fractions. Okay, let's see. That's 2 upon 4. What happens here? And also we have 6 upon 12. You can see if you multiply what? Both the numerator and the denominator by 3, you can easily get 6 upon 12. 2 into 3 it's 6. 4 into 3 it's 12. So yes, they are equivalent fractions. Okay, now let's come up with the final example. Finally, it's over. Right. So what is it? What do they ask? Determine whether 1 upon 6 and 3 upon 12 are equivalent fractions. So what I'm going to convert here, 1 into 3. What do you have to do? you have to multiply it by 3 definitely. So if you're multiplying the numerator by 3 in order to make this fraction, in order to make an equivalent fraction to 1 upon 6, then you have to multiply the denominator as well by 3. So what happens? By the same value finally, you are multiplying both the denominator and the numerator by the same value. Then 1 into 3, it's 3. Then 6 into 3, it's 18. So what happens? Are these values same? No, they are not. You can see that the denominators are not equal to each other. It's 18 and 12. But the numerators are equal. But it doesn't matter since they are not equal, because 18 and 12, the numerators are, sorry, the denominators are different. So due to that, I can tell what the the fractions, the two fractions 1 upon 6 and 3 upon 12 are not equivalent fractions, because when you try to convert it by multiplying both the numerator and the denominator by 3, then 3 upon 12 will not come. Understood? So these two fractions are not equivalent fractions. So now we have come to the end of this lesson. I hope everything is clear for you. If anything is not clear, guys, just comment. I will try my best and do my best to help you guys, and I will try to sort the questions that you have come up in the comment section, right? So practice will make you experts, will make you into experts, right? Keep practicing and keep making, find different questions from textbooks that they have given. Even though I have taught here the grade 6 maths, if you are in grade 11 and if you don't know anything about it, then go for grade 7, grade 8, grade 9, any book that you can find, where you can find the fractions, equivalent fractions, and try to make their questions that they have given in the textbooks. Okay, so practice them, and I'm sure that once the questions are done, which are in the textbooks, then you'll be an expert in this area, right? So then this is the end of the video. Have a nice day. So let's meet again with another video, which most probably I would explain about uh, the comparison of fractions. Okay, until then, have a nice day. Bye bye.